Okay, we're on to the next Higgs video. Higgs boson particle, pion decay, fermion mass size, chiral symmetry breaking. September 19, 2012 is when I started doing the research. Today's November 15th, 2012. My thoughts. How big does the Higgs particle need to be to study it? So, quote, Higgs particle mass should lie in the range of 120 to 130 GeV. I found that at www.pbs.org. So I'm exploring this keyword from the previous video. So I googled the mass particle 120 to 130 GeV. All Higgs boson particle posts come up. So I googled fermion mass 120 to 130 GeV. And up comes chiral symmetry breaking induced by fermion mass on Google. And so I look up chiral symmetry breaking to find out what it means. And quotes from Wiki is, in particle physics, chiral symmetry breaking is an example of spontaneous symmetry breaking, affecting the chiral symmetry of a gauge theory, such as quantum chromodynamics, the quantum field theory of the strong interactions. An evident consequence of this symmetry breaking is the generation of 99% of the mass nucleus, and hence the bulk of invisible matter out of very light quarks. The origin of the symmetry breaking may be described as a fermion condensate, vacuum condensate of bilinear expressions involving the fermions. The pion decay constant may be viewed as a measure of the magnitude of the chiral symmetry breaking. The Nambu-Goldstone bosons of the symmetry breaking, more precisely the pseudo-Goldstone bosons of it, are the charged and neutral pions, or more generally the light pseudoscalar mesons. Sorry. I can't say that word. September 22nd, 2012. Exploring the keywords pseudo-Goldstone bosons in the next video. So we'll be looking at that later. Another September 29th, the formula based on the data, spontaneous, symmetry breaking, gauge theory, quantum chromodynamics. So I gotta Google that to find out what it means. Quantum field theory and strong interactions. So in theoretical physics, this is a quote from Wiki, quantum chromodynamics, QCD, is a theory of the strong interaction color force, a fundamental force describing the interactions between quarks and gluons which make up hadrons, such as the proton, neutron, or pion. It is the study of the SU3 Yang-Mills theory of color-charged fermions, the quarks. QCD is a quantum field theory of a special kind called a non-abelian gauge theory, consisting of a color field mediated by a set of exchange particles, the gluons. The theory is an important part of the standard model of particle physics. A huge body of experimental evidence for QCD has been gathered over the years, so the formula is continued. So we take QCD, force, interactions, quarks, gluons equals hadrons, proton, neutron, pion, SU3 Yang-Mills theory, color charged fermions, quarks, non-abelian gauge theory. So I googled that to see what it means. So the quote from Wiki is, if the symmetry group is non-communicative, the gauge theory is referred to as non-abelian, the usual example being the Yang-Mills theory. So formula continued. Color field, exchange, particles, gluon, standard model of physics. September 29th, my thoughts. 2012. QCD came up many times in the WELL data, as well as in the SU3 Yang-Mills theory in other Higgs videos. I'll probably end up doing a cross-reference on this in the future. Thank you for watching. We'll go on to the next video now.